If you want to save deterministic time series, I got a quick tip for you. And yeah, this comes from the case where I strongly disagree with using a database. So this just happened and I saw a time series being saved in a way that I disagree with, and I want to show you a better way, and we're going to go through this on my iPad. This is basically our situation. We have some input data, and this is an array of numbers. It's like, I think we had around 10 different numbers here coming from 3 different models. So it's quite complex calculations. But what then happened is that the developer all put this into the database. So basically, I mean, the input data was already in the database. It's just like a form field that people fill out. But then the resulting time series from that, so it's like, it was basically a compound interest calculator. And the way you want to calculate those things is, of course, like compounding every year on top of each other, and then maybe some more variables. So every year we wanted to change the data a bit. And so in the end, it resulted in different days here. And we have, or you can use years, but in our case, in the example, let's use days. So every day the data changes a bit. But what is important here, that the input data determine the whole time series. So if the input data changes, the time series was written into the database, into the future basically, until how many days we would have here. And from there, we would then generate the graph. And so all these values here in the graph, they basically come from each day. And we also have a bar chart graph that came from the sum of each data. Now, storing this into the database has a couple of problems, and I quickly want to write them down here. Because the main thing is, how would you deal with data changes? And basically what happens if you change data, these 3 things would happen. When we change the data, we would need to delete all the old data, then recreate the whole time series, and then update the graph based on the sums of all these days here involved. And while this works, I think this is the wrong approach. And let me show you a better way. The better way is just to store the whole thing in memory. And why does this make sense? Because let's say we have like 100 days or 100 years and only 10 values each, and these are all floats. You would get to a final number of around 10 kilobytes. This 10 kilobytes, yes, you can store them in a database, but you can also totally reasonably just recreate them. And now that's the one thing, the one takeaway I want to put this into this video, because this is what makes all the difference. The time series is not changed after the calculation. So we're looking at this here. If you have a value, let's say this value here, this value changes. This would result in deleting everything, recreating the whole thing, and then updating the graph. One small change here would then propagate into the different days and recreate the whole time series. What that means is that the time series can be fully generated by just the input data. So this thing, we actually don't need that in the database at all. What we do need though is we need actual objects. We need classes that contain the data so we can have the calculation being done at the right point. And then we would just iterate basically over an array. We iterate over an array of objects, and then from here we would then sum up from the array, we would sum up these chart values. So in that way, the whole thing is much simpler. We don't need any database. We can code it in an object-oriented way. We don't need to deal with any kind of overhead of whatever comes from the object relational mapper, the ORM that we have here, which makes it even more complicated. So we just deal with plain objects. We don't have any database. And especially this thing is going to be faster because here we would have different inserts. So every insert goes into the database. And here we don't even have that. We just recreate the whole thing in memory. So this thing makes it faster and also simpler. I have a couple of more benefits here. So we don't need to keep the state, because the state is only here in the input data. That's our state. We don't have any state in the actual objects because we don't need it. It's all get overwritten anyway. So yes, we don't have the states. We don't have migrations. Don't need to change the database. If you want to change this whole calculation, we can just do it. No migrations. We also don't need to clean up data because we're not producing it in the first place. This whole approach is simpler and cleaner, which I like the most. And if we still need to cache it, let's assume we don't want to just store 100 years. Maybe we want to store 1,000 or 1,000,000 years. then we're slowly getting to a point where this might be hard to compute. And then we can still cache, and we can think about where we cache. We could, for example, cache it into one field in the database. We could take a Redis, because we have a Redis already in our architecture. We could throw it into the Redis. Or if we really needed to, and we think the whole thing doesn't get generated too often, then we would put it into the database if we really need to. Or we can even get a special time series database if we deal with a totally different workload. But in our case, it is really just a simple web app with a graph. And for that, we don't need a database. If you like this kind of content, if you want more engineering content for CTOs, leave me a like, subscribe to my channel, and also if you have questions, just put it into the comments. And if you want to learn more about our software development projects, especially where we start with a front end, you can watch this video about breadboards.